Hello, my dear students, with you Mr. Mahmoud Shirbini, your chemistry teacher, and today we will explain the first lesson in Unit 5 Atom Components. In this lesson, we will talk about main points as the discovery of electrons, atomic models, the concept of isotopes, and the relation between energy and mass. At the beginning of this lesson, we must know some information we have studied before at grade 7 about the atom components. We know all that the atom consists of two main things as nucleus and electrons. The nucleus contains protons and neutrons, which protons have positive charge and neutrons have neutral charge. Okay, so we can conclude now the charge of nucleus. The charge of nucleus is positive. Why the charge of nucleus is positive? Because it contains positive protons and neutral neutrons. While the charge of electrons that revolve around the nucleus is negative. Okay, so we can now conclude the charge of the atom. The charge of electrons is negative and the charge of nucleus is positive. So the charge of atom is neutral because it contains negative electrons and positive protons, while the number of negative electrons equals the number of positive protons. Okay, so the atom consists of nucleus and electrons revolving around it. The nucleus consists of positive protons and neutral neutrons. And the mass of the atom is concentrated in the nucleus. Why? Because the mass of electrons which revolve around the nucleus is very negligible if it compared by the mass of protons and neutrons, while the mass of one proton equal 1800 times the mass of electron. So the mass of the atom is concentrated in the nucleus because the mass of electrons is very negligible if it compared by the mass of nucleus, which contains protons and neutrons. The mass of proton is relatively equal to the mass of neutral, and we will study it in the next lesson. Scientists tried to explain the atom and its components and made many theories to explain it. In this lesson, we will study two models for the atom and its components. Model number 1 for scientist Rutherford and model number 2 for scientist Bohr. What's the difference between the two atomic models in our lesson? Rutherford supposed that there was a positively charged particles in the center of the atom, which named it the nucleus. The nucleus contains most of the mass of the atom. Why it contains the most of the mass of atom? Because the mass of electrons is very negligible if it compared by the mass of nucleus. And he supposed that also there was a negative charged or negative electrons revolve around the nucleus. Okay, and most of atom is space. So Rutherford supposed that number 1, there was a positively charged particles inside the center of the atom and called it nucleus. Number 2, the mass of the atom is concentrated in the nucleus. Number 3, that electrons revolve around the nucleus and most of the atom is space. But he can't explain how electrons revolve around the nucleus. Bohr atomic model suppose that electrons revolve around the nucleus in a fixed energy levels. We know that we have 7 energy levels: K, L, M, N, O, P, Q. And Bohr supposed that we can determine the number of electrons in every energy level from the relation 2 in power 2. And now we have two atomic models for explain the atom structure: Rutherford and Bohr atomic model. Now we will talk about protons and neutrons. Scientist who discovered the protons is Rutherford, and scientist who discovered the neutrons is Neil Chadwick. Protons, we know that protons have positive charge, while neutrons have neutral charge. We know that any element contains two main numbers, atomic number and mass number. If we suppose that we have element X, so it has atomic number, which is represented by symbol Z, and mass number, which is represented by symbol A. The atomic number is the number of protons or electrons, while the number of protons equal the number of electrons. Okay, and the mass number is the sum of protons plus neutrons. So the number of neutrons can be calculated from the mass number minus atomic number. So N, the number of neutrons, equal A minus Z. If we have an example for O816, so here the number of electrons equal 8 and the number of protons equal 8, while number of neutrons 16 minus 8 equal 8. Okay, if we have another example as N714, so the number of electrons and the protons equal 7 and the number of neutrons 14 minus 7 equal 7. If we have another example, Al1327, the number of electrons or protons equal 13 and the number of neutrons equal 27 minus 13 equal 14. Okay, so number here of mass number represent the sum of protons and the neutrons, but the atomic number represent the number of protons or electrons. Okay, the mass number has another concept, which is nucleons. Nucleons are the sum of protons and neutrons inside the atom. Okay, so nucleons here are 16, nucleons here are 14, nucleons here are 27. Now we will explain the concept of isotopes. We have studied it before in grade 9. We said that the element contains two numbers, atomic number and mass number. So we can define the isotopes as they are the atoms for the same element, which are equal in the atomic number but differ in the mass number. We represented the atomic number with symbol Z and mass number with symbol A. So we have, if we have an example, carbon 612 and carbon 614. These are isotopes for carbon element. They are equal in the atomic number, so the number of protons here equal 6 and the number of electrons equal 6, but they are differs in the number of neutrons. The number of neutrons in the first one equal 6 and the number of neutrons in the second equal 7, while number of neutrons in the last one equal 8. So the number of electrons equal 6 and the number of protons equal 6 for the three isotopes, but the number of neutrons are different. Okay, so the isotopes are the atoms for the same elements which equal in the atomic number and differ in the mass number due to the difference in the number of neutrons. Okay, the isotopes are similar in the chemical properties. Why they are similar in the chemical properties? Because they are equal in the number of electrons, which is responsible for the chemical properties. Okay, so the chemical properties for the isotopes are similar because they contain the same number of electrons in the last energy level. If we have another example for another isotopes as hydrogen. Hydrogen has three isotopes, H11, H12, and H13. They are equal in the atomic number, so the number of protons here equal 1, but they are differs in the number of neutrons. The number of neutrons in the first one equal 0, so it doesn't contain neutrons because the number of protons equals the number of mass number. In the second one, the number of neutrons equal 1, 2 minus 1. The number of neutrons in the last one equal 2 neutrons. These isotopes of hydrogen have different names. The first one is called protium, and second one is called deuterium, and the last one is called tritium. So we have different three isotopes for hydrogen with three different names. Okay, they are equal in the number of protons and different in the number of neutrons. And now we have finished explaining the first part of lesson 1 in unit 5, atom components. We will complete the second part in another video. Wish you all the best. Mr. Mahmoud Shirbini, your chemistry teacher. Thanks.